Hounding a little bit, Erik, I've been up to the habit mine actually.
I originally started as just a hobbyist and went out to Colorado and wandered into the mining department office of the Colorado School of Mines, told them what I was doing, and they said, "How would you like to be a graduate student? You seem to really like this subject." I said, "That sounds great." So got started in 2001, master's program, and then they encouraged me to do a PhD program, and twists and turns and setbacks and leaps forward led me to this thesis. And the topic of the thesis was leaching of uranium in a bicarbonate solution, and I used ozone as an oxidant to speed up the leaching process. And this has applications in the recovery of uranium for commercial purposes as well as for environmental reasons. For example, leaching uranium out of an aquifer to remediate it. And so this is the leaching of the uranium with just air as an oxidant, and I was able to increase it up to 51% using ozone, and then by grinding it finer and using ozone up to a maximum of 74% recovery. So I am not a geologist and I'm not a physicist, so some of the things in this might be simplified or not what you're used to, so you'll have to excuse me there. One of the things that led me to ozone as an oxidant was its high oxidation potential. So that's why we got the results that we did. You can't talk about uranium without first talking about radioactivity, because that's the first thing everyone thinks of when they're discussing uranium. So radioactivity is the emission of radiation. So radioactivity is the thing that's in the rock, and then radiation is the thing that's given off by the rock. So you can't hold a unit of radiation, but you can define a unit of radioactivity that is within the physical confines of the rock itself. So radiation causes ionization, which is the removal of electrons from atoms. So that's why it has effects on living things and non-living things as well. The four types, alpha, beta, gamma, X-rays. There's also neutron radiation, but that is not what you're going to see from radiation itself. Alpha radiation is essentially a helium nucleus, 2 protons, 2 neutrons without the electrons, and it's a large freight train of a molecule compared to the other types of radiation, but it's not very penetrating. Beta is similar to an electron. It has slightly more penetrating power than alpha, but it has basically no mass. Gamma is an electromagnetic wave that's along the same spectrum as light, radio, microwaves, etc. And as I mentioned, we have neutrons and cosmic rays, charged particles, and so forth, which we can pick up with our instruments. The discovery of radioactivity was done in a deliberate manner, but also by accident. Henri Becquerel, or Henri, because he was French, was trying to figure out why uranium caused photographic plates to fog. And he thought it might have something to do with the uranium somehow soaking up solar energy and then giving it off. But what he did was he put, the sun wasn't out one day, so he put everything in a drawer, forgot about it, and then sometime later he discovered the plate sitting there and thought, well, I'm going to develop this because it's probably going to go bad anyway. To his surprise, he saw that the uranium darkened the photographic plate without being exposed to light. So then he thought, well, maybe this is something that's coming from the rock itself and not anything to do with sunlight. So alpha decay is caused by an imbalance of protons and neutrons, which causes a repulsion in the atom, which causes it to break apart. And then when that happens, the element loses 2 atomic numbers and 4 mass numbers. And interestingly enough, this is where helium comes from. You hear about drilling for helium and extracting it and using it for MRIs and whatnot. That's where it comes from. Beta decay, as I mentioned, is an electron. And this type of decay is caused by a neutron to proton ratio is too great, much in the same way that alpha is the cause of the radiation. And so the neutron turns into a proton, which is a fascinating subject in and of itself, and the electron shoots out to balance it. So when this happens, the element gains one atomic number and the mass number stays the same because, as I mentioned before, it has no mass, unlike helium. Gamma decay happens because the nucleus is at too high of an energy state. It's somewhat similar to the way fluorescence works with light. The nucleus falls to a lower energy state and emits the photon, which is the gamma ray. And we can pick up these three types of radiation with these two detectors that I have here, which I'll talk about a little bit more. All right, so as I mentioned before, the alpha particles can be stopped by your hand. They're not very penetrating. Beta particles can go through your hand, but are stopped by a thin sheet of aluminum foil. And the gamma rays sail through this and are only stopped by thick concrete and thick chunks of lead. Water is also a very effective moderator and shielding material for radiation because it doesn't create secondary radiation. So that's something to keep in mind if you're trying to do that. So there is a theory that no amount of radiation is safe, and there's a theory that a small amount of radiation is good for you. That's called hormesis. But the truth probably lies somewhere in between. So you can't get away from being exposed to radiation because we live on planet Earth, and if you're in outer space, you get even more. So this gives you some idea of how much radiation you would get if you work in these various industries. And you notice here that flight attendants get more exposure than all of these other employees, including nuclear power plant workers. And that's because when you go up in a plane, there's less atmosphere to shield you from the cosmic rays. If you take your Geiger counter up in the plane, it goes crazy. It's almost like holding it near one of these rocks. But we don't have flight attendants dropping dead. And that's because the human body has been adapted to deal with radiation because we have evolved with it since we crawled out of the swamps. And so this gives you some idea here of your exposure. This here is the public dose limit is 1 millisievert, and this is how much an astronaut will get on a 6-month mission at the space station. So the size of the dot is relative to the amount of radiation that we're talking about here. And so a lot of these things you might not be able to read from back there, but these slides are posted online, so you can always refer back to it if you have any questions.
We'll post a link later on the club website.
Okay. All right, so this is a chart that shows you, it's a breakdown of the radiation dose that you get from all these different sources. You can see here that radon and thoron, which is the thorium equivalent of radon, has the greatest potential for exposure, and the rest is medical. And then we have nuclear medicine. You see here the terrestrial background from the rocks is relatively small, and cosmic rays are relatively small compared to radon and medical procedures. And these are the dose limits, in case you're curious. You can refer to those later. And this shows you how complicated the units of radiation are. And that's one reason people don't understand it. So you have activity, exposure, absorbed dose, equivalent dose, and then broken down to all these things. So I posted this so you could study up on it later. There may be a quiz, maybe not. But I just wanted to include that just to show you how crazy it can get when you're trying to figure all this out. All right. And these are all the conversions between the different types of radiation. To further add confusion to it, there are SI units and there are standard units and so forth. All right. And so one question I get besides, is it dangerous, is it legal? So you can possess small amounts of radioactive materials and certain types of radioactive materials without a license. And this is the Code of Federal Regulations 40.13. And as you can see here, you can possess unrefined and unprocessed ores. You can't possess fuel rods from your local Oak Ridge enrichment facility without a license. You cannot possess a giant chunk of cesium-137 nuclear waste without a license, but small amounts, 100 microcuries, which is smaller than the head of a pin. And there are companies that sell these sources that you can use to calibrate your instruments and do experiments with, and they're perfectly safe, and you don't need a license for that. Other things are grandfathered in. You might have a radium clock in your house and not even know it. Radium dial clocks have that look to them like the luminous paint that kind of turns brown after a while, and it's the radium actually destroying the paint itself. And so a lot of those clocks that were made back in the 20s, they no longer glow because they're metaminked. The zinc sulfide has been destroyed by the radiation. So you definitely don't want to take those clocks apart and get the dust everywhere. Fiestaware, the orange Fiestaware especially, is radioactive. It has, the uranium has a unique orange color to it that was really popular back then. The newer lamp mantles that you get for the gasoline lanterns, like the Coleman lanterns, do not have thorium anymore. The old ones do. Smoke detectors have americium, which is every bit as radioactive as plutonium, but for some reason, not considered dangerous, as long as you don't break it open and scrape it off and ingest it. Tritium gun sights, certain vacuum tubes, etc., are slightly radioactive. All right, so the major uranium minerals, I say major because these are the ones that are commercially mined, are carnotite, tyamonite, which is just the calcium version of carnotite, and uraninite, which is a combination of UO2 and UO3. These minerals are not generally mined commercially. They're very interesting and beautiful minerals, but they're considered minor from an economic standpoint. And so uranium is found in basically three types of deposits: hydrothermal veins, and vein type, and pegmatites. And those are the three, or basically the two subtypes of hydrothermal vein deposits. You also have the flat-lying sedimentary deposits, which in this country now are the source of most of the commercial production. As I mentioned before, the carnotite and uraninite, especially in sandstone, are very commercially viable because not only are they in large deposits, the sandstone can be easily milled. It's easy to crush and it leaches well. Uranium is found in shales, lignites, and coals, but it's low grade and it's hard to process, so not considered economic. And in South Africa, they have placer deposits that contain gold, so it's essentially a byproduct. And those placer deposits are interesting because they were formed when the atmosphere was reducing, so you have uraninite and gold occurring together in the gravels. You also have, specifically in the hydrothermal vein deposits, they're usually felsic, igneous, or metamorphic rocks. And there's a strong relationship, and this is for exploration purposes here, is you have a quartz content between 20 and 60%. It also occurs in the fractures and occurs with pyrite, base metals, quartz, hematite, calcite. This is a classic description of deposits like the Schwarzwälder in Colorado, which I'll talk about in a minute. And this is an idealized hydrothermal vein uranium deposit, but it could be the Schwarzwälder mine, which is one of the most famous mines in the Front Range of Colorado. You have three things that are necessary for a hydrothermal vein uranium deposit to form. The source rock, so you have a large quantity or large volume of granite, for example. You have a host rock, which in the case of this cartoon here is this right here, and a physical or chemical trap. Now that physical trap can be stockworks, veins, fractures that come down and basically pinch out to where it can flow through, but it slows down long enough to where the ions are depositing and interacting with the host rock. The chemical trap would include hydrogen sulfide, for example, in the Schwarzwälder mine. So you have some metasediments that were mudstone, had a high sulfur content because there were organisms that lived and died there. And when the oxygenated uranium that came from that large volume of the surrounding source rock came through and contacted the hydrogen sulfide gas, then it was no longer soluble and became uraninite. And this is an aerial gamma ray map, and this shows you, at least on the surface, where the uranium minerals are likely to be found. And so you can see that the Four Corners area, Nevada, Southern California, and then of course up here, Maine, New Hampshire, our favorite spots, are high in equivalent uranium, which is the radiometric correction for the concentration of uranium. So you have a chemical concentration of uranium, and you can use that to compare against the readings that you're getting from gamma ray detectors such as a scintillometer, and that will tell you where they exist. These are the Piedmonts here, which I'll talk about a little bit later, that have a lot of exposed rock and uranium in those rocks. And then down in Florida, we have areas here that are hot spots. Okay, so when I graduated in 2013, I went off in a different direction because the mining companies were laying people off. And so last February, I started getting nostalgic about uranium and decided that I was going to go out and I was going to visit all the locations I could find on MNDAT that were within a reasonable distance. And I was going to collect samples, and I was going to build up my collection that I had sold off along the rocks when I was in Colorado. And so started off by going to Cumberland, Rhode Island, and Connecticut, New York, and you can see all the locations here. You might recognize some of them. And the Newgate copper mine in Granby is interesting because when you think of the Northeast, you generally think of metamorphic rocks and you think of igneous rocks. This is a little bit of sedimentary rock that is just smack dab in Connecticut. And other interesting things include dinosaur footprints and whatnot. But this particular mine was mined during the Revolutionary War times for copper, and they couldn't make it economic, so someone got the bright idea to turn it into a prison. And so they had all the prisoners up above the mine, and they kept climbing over the wall and escaping. And someone said, well, why don't we put them down in the mine and force them to mine this copper, and there'll be one way in and one way out, they won't be able to escape. And so that was great unless you were a prisoner there. So decided to visit this location just because I like uranium and I like copper, and as I mentioned before, it's a very unique geologic setting. So 1741, they had spent $200,000 in $1741, perhaps, I don't know. And they only got 100 tons of ore out of it. It's also a wet mine, and so that's why they turned it into the state prison. So the interesting,
Quick question.
oh yeah,
So when they put the prisoners down in the mine, how much uranium was down in the mine?
actually the ore that came out of the North Hill mine is not as rich, or I'm sorry, the ore that came out of the Newgate mine is not as rich as the ore that came out of the North Hill mines, which is very close to Newgate. So they probably did get a pretty good radon dose, but there have been some archaeological digs done there, and they found that the prisoners were breaking open the chicken bones and sucking the marrow out. So it was probably malnutrition that was more harmful than being exposed to the radon that got them, and countless other diseases they had back then.
Okay.
So this is the geology of the area, and you can see here, here's the Newgate prison, which is a a state park. You can go visit it, go down into the mine. But up here is the North Hill mines. So I found a creative way to get in by hiking along the Metacomet Trail. And there it is, the North Hill mines. And so you can see there's the copper mineralization. And here is the stratigraphic column of the area. If you're into Stratton said, you can see here the basement is all the metamorphic rocks, and then you have this little area here. The Shuttle Metal Formation is where the Newgate and the other mine is.
Is that what you call the Connecticut brownstone?
It's more of a gray stone, so I'm not sure. I'm not the expert on
It's
this.
that sequence, but that may not be this particular rock.
Very
It's the fill of the Hartford Basin.
Yeah, so, yeah, if you want to see some sedimentary rocks, you don't really have to go that far. So as I mentioned, MnDAT is a very good resource, and so I set about trying to find places to go and collect. And the uranium occurs in these areas, which are all pegmatite areas. You have the Topsom district, Parish Rumford, Grafton, which is where Ruggles is located, the Keene district, which is Tripp and Clark, and the Middletown district in Connecticut. And so I have a few examples here: the Swamp Quarry, Harvard, Palermo, Tripp and Clark, as I mentioned, the Simpson mine in Connecticut. And so these pegmatites, as many of you have visited and know, are less than 1,000 feet long and 100 feet thick. And the pegmatites are usually underlain by the metamorphic rocks, so you see a lot of minerals along the contact of that. And they're very rich in quartz mica schist. And the igneous rocks are granodolerites, quartz monzonites, and the granites, of course, that occur in the pegmatites. And then here are some analysis and age determinations of these pegmatites, and you can see they're all between about 280 and 300. Ruggles, if I remember, is 290, is that right? There's a sign as you walk in, I forget exactly what the number is, but that's the age. They're very, very old. So Last year in August, we went to the Hewitt quarry, and Hewitt has meta-autunite, which is a phosphate mineral, metatorbanite, which is a copper uranium mineral, columbite, which contains tantalum, usually columbite, tantalite, and uraninite, which David brought in a good sample of that. He was just showing me. The Simpson quarry is a good place to collect. The neighboring property owners seem to be helpful in telling you where to park and how to get up there. And this is in Glastonbury, Connecticut, and I recommend that one. And the swamp quarry is probably the most famous, one of the most famous locations in Maine for these octagonal uraninite crystals. And it's not really a collecting location. It is part of the Highland Golf Course nature trail, and so I don't recommend that you go there and get your pick and shovel and start digging. But the nice thing is that you can go there, take readings, pictures, and look at it because there's public access. So this location was made famous by a geologist by the name of Cliff Trevelcott.
Yes, that's correct.
Yes, and he made these crystals famous. Basically, found a lot of these, and so I visited there once, and I looked at this area on Google Maps and decided that's where I was going to go, and walked all around here, and my daughter remembers this, right? You were there. And did not find the enormous crystals that I was looking for. Found a few spots that were slightly radioactive, but I thought, well, what was all the fuss about? Walked around all through here. Boy, I guess that it's all mined out. It's all gone, right? And then I...
Did I answer?
Yeah, you did. So the lesson I learned here is that there are two ways to search on MinDat. You can search for the name of a property, and you can search for the mineral that you're looking for. And what I figured out was this was actually the consolidated #2 quarry that I spent the entire day walking around and a little bit confused about. And then, oh, I'm sorry, can you go back, please? Yeah, this is the swamp quarry. So if you ever go there, make sure that you're on the nature trail here. The parking is up here, and then this is the swamp, and then the trail goes right through there.
Sorry, which one is the place with the nice pond? There's like a circular loop with a pond.
Yeah, so this has 2 ponds. This is the loop that goes past. And the consolidated quarry has 2 larger ponds. But there's not a whole lot there. The swamp quarry is where the
The swamp
The
is
good stuff.
basically in these guys' backyards, so you gotta be kind of careful.
yeah, like I said, you don't want to dig big holes and disturb anything, but you can go around and check it out. It's a really neat place. If you want to be super by the book about it, nice thing about Maine is there are public collecting areas. So Harvard Quarry and Mount Appetite are 2 great places to go if you're interested in radioactive minerals and other things too. And then, of course, Palermo. This is one of my favorite pictures. It looks like a skull. Is open to mineral groups and would be a great field trip.
We have had multiple field trips in the past, and we may schedule this one this year if someone volunteers to be a leader.
Yeah, the owners are really great. I can't say no. Good things about those guys. So at Palermo, you have a lot of minerals, but these are the uranium containing ones: autunite, clarkite, metatorbanite, uranite, I mean, the list goes on and on. It's to the point where you can't pronounce them anymore. They're so obscure. A great book is The Pegmatite Mines Known as Palermo. It's no longer in print. You probably could find a copy here in Boston at one of the libraries, probably here at Harvard.
You can get them through the owners of Palermo.
Oh, okay, so they're still selling them,
Yep.
but not in print, yeah. So my favorite thing about this book is the hand-drawn crystals. The artwork is just amazing.
He's selling these pictures, the options.
Oh, okay. So I was graciously invited to visit back in July, and the biggest problem I had was that the rock was too big for me to lift. It was 187 pounds, and so they got the backhoe out, and they were nice enough to load it up for me. Yeah, it's out by the pallet shed. So I didn't have a scale big enough to weigh it, so I went back to my engineering education, and I did the fulcrum trick here with a piece of angle iron and a 40-pound block, using the principal levers. You know, distance times weight equals distance times weight, came up with 187 pounds. And moving on, now we're in Phillipstown, New York, at the Phillips Mine. Phillips Mine is interesting because it was mined for pyrrhotite back in the 1800s to make sulfuric acid, and it also contains uranium in the hornblende. And this is some more detailed information about it if you're curious. And this is the location here. It's very close to the Hudson River and West Point. Really cool area to visit. And it is in public park, and it is a fairly easy hike up there. And then right across the river on the other side is Bear Mountain State Park. And I am a member of a Reddit group called Radioactive Rocks, and someone posted a picture, and they went there at night with a black light, and they just pulled into the area that leads down to the swimming pool, and the whole hillside was all lit up. I said, I gotta go. So when I got there, it was after dark, and I couldn't wait till first light. I had to see it right then, so I scrambled up the hill with the black light and looking around, and all of a sudden I see these red eyes, about a dozen of them. And I thought, oh gosh, it's coy wolves or coyotes or some, this is how I die, right? And then I saw a big floppy tail and figured out it was deer, so that was an exciting. It is the spot where the minerals are found is very close to the river here. So here's the coordinates here if you're curious. It's very easy access. It's basically you just pull up right next to the deposit. You can look around. I do have a sample of that right here and the Phillips mine as well. Another spot that I have visited in the past, about 1999 or 2000, is Penhaven Junction. And this is in the Poconos of Pennsylvania. This particular location has produced some fantastic examples. We have castellite here and torbanite there. I am still trying to figure out where the really good stuff is, but last year I went down there, and when I originally went the first time, there's a spot by the side of the road which is extremely dangerous and you're likely to get hit by a car. The other spot is way deep in the canyons away from the road, But fortunately, between 1999 and the present day, they turned the rail bed into a bike trail. So that opened up that area to access, and was finally able to start off here at the trailhead near Whitehaven and ride down the path. It's about 22 miles, but the nice thing is that it's slightly downhill or level most of the time. So you get a shuttle, it takes you up to the trailhead, and then about halfway down here is Penn Haven Junction. And this deposit was found by a gentleman who was riding in the caboose of the rail car with a scintillometer, and the scintillometer went crazy. This was back in the 50s, and they stopped the train and he got out, and there's several reports that have been written about this location. You can see here that there's some copper mineralization here as well. And then moving on to Cranberry Lake, New Jersey, the Charlotte or Bemco mine is another good location to visit that is in a public park. And this is a uranium and rare earth mineralization deposit. So it's more interesting to me because of all the other elements. You have thorium, zirconium, niobium, yttrium, ytterbium, tantalum, erbium, gadolinium, all the things that make modern society possible occur at this deposit. And then if you don't want to drive that far, you can always go to Cumberland, Rhode Island, to Calumet Hill. And this is Lewis. He is with the Rhode Island Mineral Hunters. And I discovered this location when I was watching a YouTube video, and someone was talking about gold in New England, and he said, oh, I've been doing research, and this isn't a gold deposit, but there's uranium in Rhode Island. Who would have guessed? So I went up there and found some good samples. And I am posing this request to the group to tell me what cesolite is, because this is the only information I can find on cesolite. And so this particular mineral or rock contains uranium, thorium, rare earths, and noble metals. So not sure what that is, but it's in the Quincy granite. And I have a sample of it right here if I want to take a look after the presentation. So I did some XRF analysis on it, which doesn't give me a full suite of metals, but found a bit of arsenic, copper, iron, titanium, which I expected to see, zirconium, and uranium. 169 parts per million uranium, which is not a lot, except it's very radioactive. So it is my belief, and also of the author, that this contains thorium. So it's probably uranothorite in there. But I'd love to get it analyzed. Another one of my favorite minerals is monazite. I find it interesting because it's a thorium mineral, which is somewhat unusual. When you're talking about commercial extraction of radioactive minerals. But it contains a suite of rare earth minerals, lanthanum, cerium. You also have neodymium. And there are different types which are more rich in either lanthanum or cerium. And then I'm going to put that monazite topic on hold just for a second and talk about the best mine in the world for uranium. And we did a field trip there last October. This is a visit that I did back in August, and highly recommend a trip to Ruggles Mine. Hoping that we're going to do this as a group this year. It's a great place to visit, and Patrick has the light, he'll take you around, he'll show you all of the fluorescent minerals as well. And
We plan on actually digging up, scratching some areas, potentially at night, for those who want to camp out, and that might turn out to be kind of fun.
so when I first visited Ruggles Mine, it was 1999, and they would only let you go into the center of the pit. And they didn't bring anything in for you to dig through. It was nice to see it, but the new owners give you excellent access to the property, and you can go through all the dumps and you find a lot of great stuff there. And so another trip that we did last year in September was the Hayes Ledge quarry, and I found this mineral here has a lot of schorl in it, and unidentified uranium oxide coating, possibly some uraninite maybe.
Yeah. And the Hayes Ledge stuff, there's a lot of stuff in the gardens for some reason. Like it'll be like a mixture of garnets and then like yellow uranium minerals.
And so fortunately the owners had an issue with a 500-pound radioactive boulder in the way of a road they were building. So we said, just take all of it. Unfortunately, I couldn't take the whole thing because I couldn't lift it, but I broke it up into chunks, and I got it out of there for him, so it all worked out for the best for everyone. This is the Turpin-Clark mine, which we talked about before, which I highly recommend. Great location, Alstead, New Hampshire. And I have a sample of that from here. Okay, so getting back to monazite, after that slight detour. These are the locations that I was able to find that contain, or are purported to contain monazite as far as MNDAT goes. Poker Hill, unfortunately, is not a collecting location anymore. It's a McDonald's. And Manton Avenue, Providence, is an apartment complex. The owners of the Conklin Quarry were very nice and let me poke around. Did not find any monazite there. There's a lot of marble and carbonate minerals if you're interested in that. You can call them up and they'll let you have a look around. Narragansett Pier, walked around a bit, didn't find much. The Sullivan Quarry, no. Redstone Quarry, they were very nice. They let me in, have a look around, but nothing. But Block Island, out here, is the place to be for monazite. And so the monazite was first found in 1891, which I find fascinating. I like this time period of all the studies and the mineralogy. And basically the monazite comes from the westerly granite, and it was outwashed by the glaciers and then was reworked by the tides. And so this is me in about the year 2000. You can see here that there's some small streaks here, but I had to use a pan to concentrate it because it was mostly quartz sand. Went back last summer and it was bonanza. The tides had concentrated it over 23 years into a very large and fairly thick deposit that went on for a while. This lady was wondering what we were doing, and we let her inspect the deposit with the Geiger counter, and she said, oh, well, I covered myself with this sand because it's warm. I said, well, most of the warmth is due to the fact that it's dark and it's absorbing the sunlight, but the thorium also might have something to do with it. So, and it is also my goal to try and find radioactive minerals from Massachusetts because, as we know from looking at MNDAT, there's not a lot really out there, sadly. But one of the spots here is 495 and 290 in Marlboro. Has anyone heard of this deposit? Yeah. So a Boston Mineral Club member, Steve Garza, anyone?
Yeah.
That sound familiar? Yeah. He did a great map of this location, and so I went to this spot here, which is rare earth granite, and pulled off the side of the road. These are.
I'd just like to be clear, this is not a legal collecting area, so you have to just warn our membership.
Oh, really?
Correct.
Oh, okay, well, learn something new every day. But these are the radioactive minerals that have been found in this area here. You have alunite, monazite, montanite, uranophane. Did not go there at night, was not able to check it with black light. But I got a fairly high reading with the scintillometer, and I have a little specimen right here, which I suspect to be monazite. One of the instruments that I can recommend here is called the Radiocode, and this is great as a radiation detector on its own, but it also does a gamma spectrum. And so what you see here is the number of counts and the energy of the counts. And the energy corresponds to the isotope that's giving it off. So these are the lines that you'd expect for a certain isotope. This is one of the decay products of thorium here, and this matches up and that matches up. So that leads me to believe that I have some monazite in that location. And so moving on, this is Uranium Tour 2024. Went down to Florida. This is something I've been planning to do since about 1998 when I called down to the RGC Mineral Sands mine there. And I said, hey, I'm interested in this. Can I come down? And they said, oh, we have labor troubles. It's not a good time. And so here we are 25 years later. The heavy minerals have been mined here in Florida for approximately 100 years. And they start up in Georgia near the Okefenokee and moving down here to a town called Stark and Green Cove Springs over here. And the source of the monazite in Florida is the Piedmont Range here, and these are the belts of granitic rock that were weathered and they were outwashed, and this is called the fall line here of where the sediment starts from the mountain range. And this is the weight percent of xenotime, which is a yttrium phosphate mineral similar to monazite, and contains thorium as well. And you can see here how it's been all washed out this way. And a company called Chemours, which was spun off from DuPont, is currently mining these heavy mineral sands here. The mineral sands contain rutile, ilmenite, starlite, a little bit of garnet in there, and monazite. And this is the source for most of the titanium that's used in pigments, and they also use it for titanium alloys as well. There's renewed interest in the rare earths because we've been dependent on China for so long for our rare earth supply that the government has declared it a critical mineral, and they're putting money into research and production of the raw materials that contain rare earths, and also for the separation of the raw materials into the various rare earth compounds that are necessary for all different kinds of electronic applications. And I was able to find it at a place called Matanzas Inlet. You can see here that digging out the sand gives you these really interesting layers here. This is Trail Ridge. This is some material that has been concentrated. You can see that it has an elevated count here. The starlight is used for sandblasting, and the monazite and the starlight wind up together, separate from the titanium and iron minerals that go off to a different stream. And so here is a close-up picture of the monazite from Trail Ridge. You can see that the grains are very rounded. In the previous map, you saw how far they had to go. They traveled all the way from the Piedmonts to Florida, and in doing so, they were worked and reworked by the change in sea level due to the ice ages. And so what you have here is very small, well-sorted, very round grains of the Trail Ridge monazite. This feature is working. That's plain polarized light. Right. Next one. Okay, and then this is the Block Island monazite, where you can see the grains are more elongated, they're larger, and they're not as well sorted. This right here is a quartz grain under polarized light here. All right. Okay, so what's next? I really want to try and find some more radioactive minerals in Massachusetts. And I understand that there have been some radioactive minerals found at the Rollstone Quarry in Fitchburg, which is a publicly accessible location. And you can see here that in addition to the radioactive minerals, there have also been a number of other collectible minerals found there. I don't know if the location's been picked over. Someone might be able to give me a field report and tell me.
It's for Shoral, it has beautiful Shoral specimens. It's hard rock mining.
Yeah.
So, you're banging on stuff that's, frozen in quartz and quartzite, and, it's just hard to get out.
Right. Yeah, and the other downside is that it's been graffitied, so it's not as beautiful as the locations we're used to in Maine and New Hampshire. But
Yeah, it is the local hangout.
yeah, so best to go in the daytime. But I still want to check it out. The Worcester Mineral Club has an interest in getting a group together to go for an informal visit. Also, got to make it up to North Conway to see the Redstone Quarry. Has anyone seen this? So this location is interesting because it has a history trail with plaques that show you how they mined this granite, and some of this wound up in Boston for some famous buildings here, but it was mined as dimension stone, and some of the old machinery is still there, some steam engines and some winches and whatnot, and the trailhead is right behind the Walmart, so it's not a very hard location to get to. It's just a fair amount of driving involved. And it's the minerals that have been found here. You can see the usual suspects, the alanites, the columbites, and thorites. So, got that on the schedule. And also, the Aggregate Industries Quarry, there was an excellent write-up on the minerals that have been found here, and I contacted the owners. The company is called Holcim. They're no longer Aggregate Industries, but he was very interested in having a group come up to do some collecting. When I went there, they let me drive along this area here and collect some crushed stone, but they didn't have anyone that was available to babysit me to check out the high wall here in the area where all these minerals have been found. These are monazites from this area here, but can you read this in the back, all these different minerals that have been found there? So
Yeah, it's actually a good location for fluorite.
yeah. Yeah, so we have an inn if anyone wants to go. It's not really too far to drive. And they said in spring was good for them, when the snow melts. That is the end.
Question.
country on it, and then the Southwest seemed to have some pretty big blotches. Is that natural? Is that from nuclear testing? What's that from?
Not nuclear testing. The amount of uranium in the rocks is higher there, but it's also more exposed. So if you can imagine the Grand Canyon, you see pictures of that. It's just mesas and sand and very little overburden to block the radiation of the soil.
You didn't really touch on the safety and storage, et cetera, of these things.
Right. So the main issue with collecting and storing radioactive minerals is the dust that it creates. So if you're working with it, you don't want to be grinding it and getting the dust everywhere. So when I'm working with things that I don't want to breathe, I usually do it outside, and I set up a box fan, so there's always some kind of air movement. The second issue with storing radioactive minerals is the radon that gives off. So I just have an outdoor storage area, a shed. I keep everything in the shed, so I'm not around it all the time. So yeah, I would recommend that if you collect these minerals, you keep them in an area where you're not going to get the dose from the gamma radiation, and you're not going to get the dose from the radon. So
Not under your bed.
it's what?
Not under your bed.
Not under your bed, no. And there's not a whole lot difference here. So I get a background of about 100. Standing over here, it's going down, it's 85. And then, so you can see it picks up a little bit, but it doesn't really start screaming. It's the inverse square law at work there. So similar to how light behaves. Double the distance, more worth it does.
Do you have any information like on the brand of detectors and how they use, or what works, what doesn't?
Yeah, so I highly recommend this combination. The Radia code, as I mentioned before, is a gamma spectrometer. It hooks up to your computer or your Android phone. If you're on the run, you can use it. It's lightweight. It's $320 on Amazon now or something. I haven't checked
A
lately.
little more, but
Yeah, $350.
it's worth it.
What's it
Um,
called
A
again?
new model and the
Radia.
price.
Radia.
Yeah, they have a new one with a larger crystal in there. It's like
Radio or radio?
it's a Radia code. And the nice thing about this is the scintillometer, so it detects radiation at greater distance than the Geiger counter. And so you can have this in your car, or if you're walking around, it'll detect the uranium from farther away. But the Geiger counter is still king for detecting low levels of radiation, like if you're looking for monazite sand, for example, which tends to be fairly low emissions. You can use this. If you're in a pile that has a high background and you want to zero in on something, the Geiger counter does the trick. So this is a radiation alert ranger. And so, yeah, this is the pairing that I recommend the most, that you'll get the most use out of it. And it fits in your
So
pocket.
Eric, the scintillator only detects gamma, is that correct?
That's correct. This
And
one detects gamma. This is alpha, beta, gamma. And this also has a pancake probe. So if I peel off the back here, you can see this. So it has a large surface area, and so it detects, as I mentioned, very minute changes in radiation background, as well as if you're looking for a contamination, for example, if you have a radium clock that breaks and stuff goes everywhere. It's good for sweeping countertops and finding little specks of contamination as well.
I have a
Honestly, just contamination. Oh wow, so that one really has a feel.
And like I double checked it like a year later, and it was leaking a bit of radiation, which I wasn't too happy about. Yeah. So I had to get like an entire shed in the backyard to like, get some distance.
Oh wow, dang.
Yeah.
That's huge.